Sets in Python. Let's talk about sets in Python, accessing, deleting and updating them, functions, methods and operations on them. We'll learn to iterate on sets and also learn about the frozen set. Sets are collections of values that are unique. Sets hold no duplicates. They are unordered and do not support indexing. This is a set. It can also hold different kinds of values at once. So what happens if we try to add duplicate elements? Well, it holds only 1, 2. You can also create an empty set, but use the set function for this, because empty curly braces create a dictionary, not a set. You can also use the set function to create a set with values this way. Like lists and dictionaries, sets are mutable, but they may not hold mutable items like lists and dictionaries. If this is set B, we can either access it by its name or print it, but we cannot slice it this way. And because the set is not indexed, we cannot delete items using the indices. If this is set numbers, we can discard the value 3 and remove the value 5. But how are they different? This set does not have 7 now. If we discard 7, it does nothing. But if we remove 7, it raises a key error. We can also pop an arbitrary number and clear empties a set to give us an empty set. To update a set, we can add an item to it, and again, but 4 is already in it, so okay. We can also update it to hold values from this list 7, 8 and the set 1 to 9. Let's discuss some functions we can call on sets. Days is the set we'll be using. Len tells us how long a set is. Days has 7 items. Max gives us the highest value in a set. 3 is highest here. And Wednesday is the greatest, comparing by ASCII values. But we cannot compare values in this one. Strings and integers are not comparable. Min gives us the lowest value in a set. In days, this is Friday. Sum gives us the sum of all elements in the set. 1 plus 2 plus 3 is 6. And we cannot add strings to integers. If even one item in the set has a true value, any returns true. 0 is not true, but the string 0 is true. And all returns true only if all items in the set have a true value. 0 is false here, but days has all values true. Sorted returns the sorted version of a set. If this is the set numbers, this function returns its sorted version. And now some methods on sets. We know that mathematically, sets support various operations like union and intersection. A union returns the items in any of the sets. This is the union of A and B, everything. Calling union on set 1 and passing set 2 and set 3 to it gives us the union of the 3. An intersection gives us only the common elements. This is what's in A and also in B. 3 is common to set 1 and set 2, and nothing is common between set 1, set 2 and set 3. Difference returns the set difference. What's in A and not in B? What's in B and not in A? 1 and 2 are in set 1, but not in set 2. And the same for set 2 and set 3 with set 1. Symmetric difference returns all items that are unique to A and those unique to B. Set 1 and set 2 have the element 3 in common, but rest all elements in them are unique to them. Intersection update performs intersection and updates the set with the result of this intersection. This is the intersection. Updates set 1 with the intersection of set 1 and set 2. So now set 1 holds just the element 3. Similarly, Difference update updates a set with the result of a set difference. This is A minus B, so this removes 3 from set 1. Symmetric difference update updates a set with the result of a symmetric difference. This is the symmetric difference, A minus B and B minus A. So other than 3, we have 1, 2, 4 and 5. These were functions and they do not alter a set except for the update functions. Now let's talk about methods. Copy creates a shallow copy of a set. Shallow copy of set 1, call it set 4. Is disjoint returns true if two sets are disjoint and have nothing in their intersection. These sets are disjoint, but we cannot pass more than one argument to this method. Is subset checks whether a set is a subset of another. 1 and 2 is a subset of 1, 2 and 3. And it's also a subset of itself. And is superset checks the same for a superset. 1, 3, 4 is not a superset of the set 1, 2, but it is the superset of the set 1. And now some operations on sets. We can test membership on sets. Is the letter P in this set? Yes. Is 0 not in this one? Yes, because we have a string 0, not the integer 0. We can also iterate on sets like we do on lists. For each item in this set, print it. And now let's discuss frozen sets. These are immutable sets, and since they are immutable, we can use them as keys for dictionaries. This is a dictionary with a key that is a set. It cannot be. But neither can this. We can only provide one value to the frozen set function, so provide a list to it and you'll create a frozen set. And that's all about sets. Next, let's discuss booleans in Python.